Good morning, everyone. We will start. The first session is a special topic for IROC 10. Last Friday, we already mentioned we have ongoing discussion to reformat BUFR, and this is, there's a lot of additional requirement or information we would like to add. So I invited Stig and Neil, who have been working very hard together with other people on this, to give us a presentation. You won't see every detail, but I hope at least you have some idea what's coming into this BUFR format. And we are hoping to hear from you. And I assume, Stig, you will tell us the deadline about this. And we are hoping you can contribute to this work as well. Thank you.
Okay, thank you. So I have the privilege to present this. We've been a small group of people working for the past year or so.
Could you move a little closer to the mic, please?
We have had some technical advice from Jeff Ader from NOAA and Simon Elliott also from UMassat. So I'm going to go through a few slides in a moment. But I want to say first here that we need your help now. You should have an email or maybe even two with the proposed changes to the BUFR in section 4, the data section of the BUFR. It was sent to you both from the IROC mailing list and also to all participants of this meeting here. There's still some remaining questions, and if you have any answers or ideas or comments or anything in this document, let us know. We would like to get your feedback by 1 month from now, Friday, 18th of October. So that would be very helpful if you can give us some feedback on that date, before that date. We are aiming for a May, the WMO meeting, where we will then present the final proposal. But we have a long road ahead of us. We need to prepare the changes well in advance, and we actually also talked about that we would like to try out to actually code the new BUFR and decode it and see if everything is working out well. That means a lot of programming first and stuff like that. So that's why we are here now today, that we ask for your feedback to get this finalized. The main changes that we have made here is and that we propose is the capability for the polarimetric RO and the airborne RO. There are some additional diagnostic fields, and it's made in a way so it's easy to add future diagnostics in the future in a new code table. We want a new flag table. It's yet to be finalized. I'll come back to that later. There are some explicit descriptors for estimated errors of measurements, which are replacing the previous or the current RMS descriptor that are in the BUFR. So the changes compared to the current BUFR are marked in blue in the following slides. And I'll go through some of those, or maybe most of those actually here. Not in detail, but just so that you get an overview of what it is. The first one is the Vigo station identifier. It's required for all new BUFR formats, so there's not so much we can do about that or say about that. This is a new thing in the new BUFR. So we have some introducers for satellite or aircraft data. So we have changed the satellite introducer a little bit. So it's going to be a new descriptor. It has 3 descriptors, and one of them is the satellite sub-identifier, which was included in the buffers recently. Then there's some other identifiers that has been taken out of the current satellite data introducer and put somewhere else. We have done that because we then, down here, we have a aircraft or station data introducer. So it's kind of either this or one of these down here. And I say one of these because there are not only aircraft, but also possibility for balloon or maybe a mountain receiver in the new BUFR. We have introduced a descriptor of straight line tangent altitude at the reference time in the buffer. We have specified the start and the end of the occultation, which in this way indicates a time span for the following data. We have these new diagnostics for whole profile. And I would like to ask also if there are more needed. You can think about that when you give your feedback within the next months. Step 1B, as it is called, bending angle data. We have added time information to the occultation. We have the polarimetric RO and accuracy changes here. We have a new satellite channel center, which includes more precise information about the frequencies. So it includes all current GNSS systems and up to 6.7 gigahertz if there should be something like that in the future. We have down here, we have the calibrated phase difference, and we have this estimated error in bending angle and estimated error in calibrated phase difference. We have the ARO or station RO section. It's a whole section here, and it includes the height of the RO antenna, the atmospheric reflectivity at the antenna, and then the partial bending angle and the estimated error in that. We have some flexible diagnostics, so these are vectors. So first, there is a descriptor saying which type it is, and that's going to be in a new code table. We have made it so that it can span many orders of magnitudes, because there could be different types which have totally different orders of magnitudes. They have to be unitless, because they are all in the same descriptor, which is this scale diagnostic here. So it's a little you might find it strange when you see it, but it's the way we have chosen to do it. So it's very flexible in that way. The step 2A reflectivity data, we have added geopotential height and also dry temperature as a diagnostics. We don't expect anybody to actually assimilate dry temperature, but they could be used as a validation measure. We have also here increased the accuracy of the whole block here, so that the height and the geopotential height, the reflectivity and so on, they are now about 1 order of magnitude more precise than they were before, which also matches what it is in bending angle more or less. Also in the reflectivity section, we have these flexible diagnostics. So that's the same kind of sequence than in the bending angle section. Level 2B, 1D VAR data. Also here we have introduced estimated errors of pressure, temperature, and specific humidity instead of these previous RMS descriptor. There are two main questions that I would like to say here. It's one of them. The first one is we'd like to know which bits in the old or the current flag table are used by the NWP centers. That will help us to finalize the new flag table that we are planning to design. The second question is do we keep the level 2B data in the new buffer? We discussed it a bit, and at the RAMSAF user workshop, there was also a question on should we still keep level 1B in the buffer. So that's a question I'd like to hear your opinion about also. So this is just the first slide again. We need your help now. And if you have any comments now, we are happy to hear them. But otherwise, we would like to get feedback from those that are interested in this by Friday, 18th of October. Thanks.
Any question? Rob?
So based on what I said yesterday, you know, these occultations are sliding fibers, especially at low latitudes. And obviously we'd like, well, we're going to be working on a retrieval method to treat these things as individual planes and let the, you know, let the bending angle versus impact height vary, you know, with lat and lon, time and lat and lon. The buffer format right now, I don't think can handle that.
So what would be needed, you think?
And you think because
in principle, I think it could maybe because it has latitude, longitude, and impact parameter, and
okay,
they may not be required to be monotonic. So if they are non-monotonic, that's the issue. That's the idea, right? It could be maybe
non-monotonic, and so you can have the same impact height, same bend, a different bending angle, but the reason that works is because it's a different lat long.
Yeah.
So if you think that can handle it, that's great.
So I think we have multiple bending angles anyway.
Christian, can you go to the speaker?
Can already put multiple bending angles in there, and we distinguish them by frequency. And if we set the frequency to 0, we say that is the main neutral atmospheric bending angles. You could think about.
No, that's not the kind of multiple bending angle Rob is talking about.
No.
Okay.
But what we could do is we could say we could have small numbers 1, 2, 3 for additional bending angles that are then kind of an additional bending angle profile for the same occultation, which are only covering part of the altitude range, which is what you need, I understand.
As long as you, I mean, you've got to say the lat and lon's got to be different for those different.
I understood Rob's question as just for one frequency. If there was just talk about one frequency, that could be multiple bending angle or multiple bending angles to the same impact parameter. That's what you were saying, right?
Yes, that's right. But the lat lons have to be different.
Yeah, exactly. Yes. And I think in principle that is there. How to use it would be maybe a challenge. I don't know exactly how that would be used.
I mean, the first order problem is, can we even get that information into it's flexible enough to handle?
I think we can, but let's think about it, and you're also welcome to think more and give us more feedback. Yeah.
So Stig and you, are we going to have any meeting, or are we still planning to have some subgroup meetings for this, or in the following month?
I think as the group here we would meet again, I think, right? Online a few times at least. I don't know if we need to meet before the 18th of October. Probably not. But when we have feedback, we would, of course, meet. Was that your question or what? Yeah.
Yeah, I think if we are going to have a meeting, we can invite Rob into the meeting.
Yeah, we can. Anybody who wants to be involved in this are welcome, of course. Sure. Just let us know if you want to be part of these meetings. Yeah. Of course. Yeah.
Any other questions? Okay, so I think it's hard to ask questions without looking at the document. So